In section 14.3, we're going to be talking about polar coordinates and how we can use them to our advantage to solve these iterated integrals, depending on the geometry of the region over which we want to integrate. Sometimes it's going to be much more convenient to use polar coordinates. So if we have a function of x and y, we want to integrate over the region R, then we can instead integrate over the same region R, the function in terms of r and theta, where we make the simple substitution. X is r cosine of theta, and y is r sine of theta. And you can see I've written J here. J is the Jacobian, which is the determinant of the matrix del x del r, del x del theta over here, del y del r, and del y del theta. The determinant of this matrix will be our Jacobian. And by the substitution we made, that should be the determinant of the matrix. Partial of x with respect to r is just going to be cosine of theta. Partial of x with respect to theta is going to be minus r sine of theta. Then the partial of y with respect to r is sine of theta. And the partial of y with respect to theta is going to be r cosine theta. When we take the determinant, we get cosine of theta times r cosine of theta minus r sine theta times sine of theta, which is r cosine squared theta plus r sine squared theta. If I factor out the r, I know that cosine squared theta plus sine squared theta is simply 1, so this is r. So the change of variables is going to be r dr d theta. So we'll look at some examples of that later, and I can show you this again to remind you at that time, but let's first start looking at some regions over which we might want to integrate. So the first problem here says use polar coordinates to describe the region. Now clearly I have a circle, and if we remember how to find the equation for a circle, we'll need to know its radius, and we'll need to know its center. So it looks like my circle is centered here at 0, 3. This point up here looks like 0, 6. And down here, of course, 0, 0. So I have a circle of radius 3 centered at 0, 3. The equation for that circle should be x squared plus y minus 3 squared equals the radius squared. I know the substitution I'm going to make is x is equal to r cosine theta, y is equal to r sine theta. So I'm going to say this is r squared cosine squared theta when I square x plus r sine theta minus 3 squared is equal to 9. So I have r squared cosine squared theta. If I expand here, I get plus r squared sine squared theta minus 6r sine theta plus 9 equals 9. So that's, here I just get r squared minus 6r sine theta, and I can say equals 0. So r squared is 6r sine theta. So r is 6 sine of theta. I'm just dividing by r on both sides, and I know that my radius is non-zero, so that's okay, I can do that. So then if I want to describe this region, I'm going to use set builder notation. And I'm going to say, this is the set of all ordered pairs of the form r comma theta, such that. I said that my r was between 0 and 6 sine theta. I also need to know about theta. So I'm going to have theta maybe between some angles. So I can go back to my substitution here, or what I solved for, r equals 6 sine theta. What if I plug in theta equals 0? So if theta is equal to 0, sine of 0 is 0, so that's 0. So that gives me this point, 0, 0. What about if theta is equal to pi over 2? Sine of pi over 2 is 1, so I get 6. So that gives me this point, 0, 6. And theta equals pi. Well, sine of pi is 0. So here I am back at 0. So that tells me that I just need to take theta between 0 and pi to get the entire region. So that will be this set, this region described as a set. R is between 0 and 6 sine theta. Theta is between 0 and pi. Let's look at one other quick example of a region we might want to integrate over. This is called a rose petal region, and I'm just going to tell you how this region will be described. So we need to know the radius. The radius is clearly 4. And then I'm just going to count how many petals. 1, 2, 3, 4, 5, 6, 7 petals that my flower has. And so I'll say that this is the set of all ordered pairs r comma theta, such that r is between 0 and the radius, 4, times the cosine of the number of petals, 7, times theta. And I take theta between 0 and pi. So that's just a form that you would kind of maybe memorize, recognize. You just need to know the radius and the number of petals.